Hello and welcome to the Whole Health Cure. This episode is the first of a two-part series on exercise. In this episode, we'll talk about exercise as it relates to our health and longevity and its effects on our cellular gene expression. We'll talk about what our bodies need from the standpoint of exercise and movement. And in the next episode, we'll get more into the specifics of designing an exercise program. I'm joined by Dr. Peter Sprague. Dr. Sprague holds the positions of Assistant Professor of Rehabilitation Medicine and Assistant Professor of Orthopedics in Emory University School of Medicine. He's a board-certified clinical specialist in orthopedic physical therapy and currently serves on the committee of content experts for the American Board of Physical Therapy Specialists. Dr. Sprague has extensive clinical experience working with high school and collegiate athletes in an interprofessional team setting and has assisted in the development and implementation of screening procedures assessing for musculoskeletal injury risk for collegiate and professional sports organizations. Peter, welcome back to the podcast.
Thank you, Sharon. Great to be here.
Yeah, I'm very excited to have this two-part conversation because there's so much complexity behind exercise, how it works, why it works, how we should be moving, that I wanted the chance for us to really get more into kind of the specifics. I think, we in healthcare tend to say, go diet and exercise. That's not a whole lot of guidance for our patients. So let me just start by asking you to help us connect what we're seeing in terms of disease or longevity and trends in aging and how exercise relates to what's going on in terms of health.
Well, I think maybe the biggest piece of that is to recognize the effects of physical inactivity. I mean, not just even formal exercise, but the lack of physical activity as it relates to non-communicable diseases that are considered lifestyle diseases, things like type 2 diabetes, hypertension, cardiovascular disease, stroke. All of those things are thought to be preventable and mitigated by physical activity or exercise. And as we're seeing populations grow, we're seeing more of a prevalence and incidence of these problems, and largely they could be preventable.
And I want to really get more into the magnitude, right? I think a lot of people have a sense that exercise is good for them. But what I find is just so profound, and maybe you can speak more to it, is just the magnitude when you're saying, yes, it's, inactivity is a risk for all these diseases. There are certainly, other risks and there are other ways to manage disease, but how does exercise fit in this larger scheme in terms of how impactful is it?
I think it's very impactful. And the reason why is because it's in line with our physiology. If you look at our physiological processes, they're set up to allow for success within our body systems through movement. And the less movement that a person's body undergoes, the more problems that seem to occur. As far as the identifying physical inactivity as being a big issue, what brought my attention to it was maybe about 15, 16 years ago, I saw an article in the British Journal of Sports Medicine that identified physical inactivity as the largest global health burden that's going to face us this century. And so I looked into that a little bit more, and the link to non-communicable diseases is very apparent. When we don't move and when we don't exercise, we have cellular processes that go awry. We have cells in our body that are stimulated to kick off certain functions in our body systems that allow for normal functioning of those systems. And if we don't move and don't exercise, and we don't access the protein replication, the activation of co-transcriptors within our DNA that kicks off the good cellular processes that form proteins that allow for normal function. An example of that is our cardiovascular system. Our vascular system itself relies on consistent, moderate levels of activity. We need to increase our heart rate, and that provides or improves the pliability of our vasculature. I mean, vascular pliability may be one of the most important health markers that we have in our body. And if we're not exercising, we're not allowing some of our body's systems, especially the cardiovascular system, to gain those benefits. There was a good study that looked at the effects on the body's vasculature following exercise in older individuals that were sedentary, over the age of 65, I believe it was. They looked at a single bout and then several bouts of exercise, and then looked at the performance of the vascular system afterwards. And they found that even with short bouts of exercise in older individuals that had changes in their arteries, those changes were in some cases reversed. Right, you had more pliability within the lumen of the artery itself. It opened a little bit more, and so there's significant response just to lower levels of exercises, even in folks who are physically active typically.
What I think is so fascinating is that, our bodies are certainly wired to need a certain amount of activity for our body to really function as it's meant to function. And how we perceive chronic disease, right? So we view it as disease, but in a lot of ways, as you're just explaining, it's a lack of giving our bodies what it needs to function as it would like to function, right? In terms of our vascular system, et cetera. And some of that is at a physiologic level, right? As you're describing how it affects your blood vessels. And some of that is at a cellular level. At a cellular level, when we exercise, you mentioned, we express certain genes that affects the proteins that we end up, kind of making, because that's what our genes do. What is the function of those genes? Like, what are we activating? What types of proteins are we turning on that result in these physiologic changes?
I think the big one that comes to my mind is the PGC1 alpha. It's in the family of transcription coactivators that allow our DNA to start to ensue its functions on our body systems. What this transcription coactivator is involved in is improving the biogenesis of our mitochondria. So it helps improve the health of our existing mitochondria and then start to add more newer mitochondria into our muscle for energy. It's also a transcriptor that's involved in telomere lengthening. And if you think of what telomeres mean, perhaps it's the best understanding that we could have in regard to our aging process. So telomere length is directly related to maybe our biological age, not necessarily chronological age. And this gene itself is activated through exercise. There's a good study that came out of the University of Iowa, out of their PT department, that looked at exercising muscles that typically aren't used. They used spinal cord injury patients as subjects, and they stimulated the muscle very strongly through electrical muscle stimulation. And they found that through strong electrical muscle stimulation, they stimulated this gene even in muscles that weren't used to working. So there's the exercise input into our muscles, into our cardiovascular system, and for our bone health, et cetera. It's far reaching. It starts to kick off against cellular processes that are driven by our DNA. I think physiologically, we were set up to move. And the proof of that is that we're here as humans. Or I believe we outcompeted. I believe there were 17 other hominids on Earth that we outcompeted. And our physiological processes allowed us to migrate, to find food sources, to go to areas at specific times of the year through migratory processes that allowed us to access those food sources and shelter, et cetera. So we have a physiology that's based upon movement. We hunted, we gathered for the vast majority of our existence. Only in the past maybe 100 years or so, we had the conveniences of modern life, and our environments have changed significantly. But with those changes of environments, as quickly as that's happened, our physiology is not going to adapt or evolve as quickly. So we still have a physiology that thrives on movement, and we're functioning now in environments perhaps that make us more sedentary. And it's not just the physical environments, but it's the attitudinal environments as well. I mean, you go into any classroom setting or any meeting room, and you're going to see the room dominated by places to sit right? And so we're not used to doing that. We've gotten very good at that. We've learned how to do that at a very young age. We go into kindergarten and we're taught to sit down at the age of 5, and you're expected to do that for the next 15 to 17 years and avoid movement for the majority of your day. And so I think our physiology, based upon our evolution and where we've been as humans and what's needed for our survival to this point, it's not being utilized in the same manner. And I think that's why we're seeing such a high degree of non-communicable diseases. We have what I kind of just described as a theory called evolution mismatch theory, where an organism functions well in a certain set of circumstances, but once the environment in which that organism functions in changes, then that change could result in the detriment of that organism. So a lack of physical activity is going to go against our natural physiology. We need movement to produce the proteins that allow us to build muscle, to maintain bone health and bone density, to improve our vascular system, et cetera. And that all starts at the level of our genetics.
Yeah, and as I'm listening to you, Peter, I'm thinking we really should be doing this podcast standing, not sitting.
I was going to say that.
I was going to say I'm already feeling guilty that I'm sitting as I'm listening to you. But this tie into how exercise is built into our genome, like it's a part of our DNA and such a fundamental part of how it makes our body function. I mean, it's so deep rooted, right? Millions of years that it's been what has helped us thrive and survive. Can you put it in the perspective of how much activity did our ancestors have and how that compares to activity levels today?
Well, today, if we look at an avid exerciser, they may have 300 active minutes per week. And that would be someone who's probably doing some long distance endurance training or a serious CrossFit athlete, someone who's very active, maybe even at work with certain jobs or professions, promote that type level of activity. And they would have 300 hours more than perhaps a sedentary person has in regard to active hours per week. If you look back at hunter-gatherers and even into agriculture, because the estimation of caloric expenditure between folks who are farming versus those who are hunting and gathering is about the same. The difference between our current active exercisers at 300 active minutes per week, it's tenfold in the hunter-gatherer early farmers. 3,000 active minutes per week is what they were undergoing, and probably with, ironically, more rest, a little bit more downtime, which is ironic. So a lot of our time that we're awake and active and doing things are spent without really physical activity, or our activity mostly in these days, and especially in Western culture, is more cerebral in orientation, I think, and less cerebral plus physical. It wasn't that they weren't cerebral, very cerebral. You had to be a problem solver to survive. And in some ways, maybe they were more cerebral in regard to understanding how to survive within their environments. But what we've done now is taken that thought and made ourselves a little more sedentary, largely through, I guess, convenience. I mean, if you think of all of the technologies that make our life a little bit easier, that really takes away our movement. If you think about it, our washing machines, and probably right now at home, we have our Roomba robot vacuuming our house, so I don't have to worry about doing that at a later point in time. And our cars allow us to go further distances, but all those things just take away our movement. I don't know about you, but like, it's not saving me much time. I'm still very busy, right? I don't have more downtime because of it. I'm just filling my downtime with other activities, maybe that are involve more sedentary behaviors. So I think in a large part, our environmental changes have resulted in a lot of the problems that we see today.
Exactly. And as you just put it in the perspective through, there's a tenfold difference between an avid exerciser. What you mentioned is 300 minutes a week is already double what the CDC recommends as just physical activity guidelines. And a lot of people, statistically, a good chunk of our population is not even meeting the physical activity guidelines. So the many orders of magnitude that we're deviating from what our ancestors did is really profound. Can you talk about the a minimum effective? Is there like a minimum effective amount of exercise where we can activate enough genes, enough of the master, regulators of our genome, the transcription factors, where we can reduce our risk significantly of a lot of the chronic diseases?
Yeah, it's been defined by the CDC, and the recommendations are 150 minutes per week of moderate physical activity or 75 minutes per week of vigorous physical activity. Moderate being walking at a brisk pace, vigorous being more activities like cycling, swimming, running, etc. In addition to that, they also recommend strengthening your main body parts, main body regions, and you can do that with compound exercises or isolated strengthening, etc. They recommend that twice a week for each major muscle group.
Mm-hmm. And so that's, I'm sorry, a minimum amount, right?
That's the minimum. That's the minimum, right? If you double that, then you need to increase your health benefits even more. And it seems like the more you do, provided that there's enough physical recovery, the better off your health is. There may be diminishing returns. If we look at ultra endurance athletes, there is a thought, and I've read previously, and I don't know if this is, I apologize for not knowing if this is the current thought, but I believe that there is an increase in early mortality in ultra endurance athletes. So there may be a tipping point where there's too much activity that could be detrimental to our health.
Yeah, like a bell-shaped curve. And I think, for most people, that's a level that far exceeds, I think, what most people would come close to, though, right?
Oh, yeah. Yep. I wouldn't be afraid of physical activity.
Yeah. And the term that we're talking about right now is physical activity. So it's physical activity guidelines, but there's also the importance of avoiding sitting time and being sedentary. And then there's movement as different than exercise and physical activity. Can you talk about the terminology?
Yeah. So movement encompasses a lot, even probably beyond what we would normally think. Just my eyes going from my screen to focusing on a picture I have on my wall on the other side of the room, going back and forth, that's movement. My eye muscles are being activated in a different manner. And it's healthy for me to be able to do that. I position my desk at home where I can look out a window across the room and I can see trees. What I try to do is I'm focusing on my computer screen and try to look out the window every so often and try to look at the individual leaves to try to provide a little different input to my eye muscles. That's a movement process. Singing is a movement process. Phonation, et cetera, that's movement. So movement can be a static process, and it can be physical activity. Even though I'm not raising my heart rate, there's still some benefit in doing the things that I just described. If you look at physical activity, things like gardening or shoveling or digging or doing yard work, et cetera, that will allow you to expend a significant amount of energy. And that's good to do. It's almost on par with some of the moderate activity or moderate exercise recommendations that the CDC has. We have this thought of non-thermal exercise genesis, where we're not formally exercising, but our movement favors our physiology in that way. So maybe it's not formal exercise, but you are doing physical work or physical activity with a certain activity, like I mentioned, gardening, yard work, even house cleaning, et cetera. All of those can be very meaningful tasks. And the thought is you're not sitting or sedentary during those times. There's a physical movement component that's taking place. And that promotes longevity. We don't have to go to the gym and exercise formally. We can get our physical activity or movement processes through other means. But often we don't, which is why we have to supplement our physical inactivity with perhaps gym exercises, et cetera. If we sit for 8 hours a day, that can be detrimental, even if you're running 4 or 5 miles a day. So the running almost doesn't offset the static sedentary sitting time. What we've migrated to now is looking or exploring at maybe a 24-hour activity cycle. Rather than how many active minutes you have per day, it's how are those minutes interspersed throughout that day. The really nice thing is if you look at the CDC guidelines, and again, these are all based off of research. If you do just 10 minutes of activity, that's beneficial. So even if you work in a sedentary environment, as many of us do, we have to sit at our computers for long periods of time. If you intersperse just 10 minutes of brisk walking, you're going to bump or improve your health by doing that. And you don't have to do, maybe if it's just a couple times in the morning and a couple times in the afternoon, and another walk at lunch, 10 minutes. If you do like 3 to 5 10-minute bouts of walking, you're going to improve your health significantly. And if you think of it, if you do that 10 minutes, and it's even if it's just 3 times a day, you're over a 5-day work week, you're already meeting the minimum requirements of what the CDC recommends for moderate levels of activity. So just by adding a little bit more activity into a sedentary work structure or sedentary lifestyle, you can improve your health relatively significantly. When we start to consider things like strength and strengthening, that is a really big variable for us to consider, especially as we age. When we get past the age of 60, we get into our 60s and 70s, you start to lose strength and you start to lose lean muscle mass. I think strength loss is about 1% per year when you reach those decades, and maybe you're losing about 2%, 1.5% to 2% of lean muscle mass each year as well. The problem with that is if you look at what occurs because of a lack of strength in older populations, it increases mortality significantly. And what I'm thinking of is falls, right? You have fall risks. You have that's basically the trauma that results in early death or early mortality, even over the age of 60. And we think of 60 as being really young right now. There's a lot of falls that occur. And if you look at the variables that are related to falls, it's power and strength, a lack of power and strength. In fact, if you look at the hazard ratio of strength deficit, strong versus not strong, it's about 3. It's a little over 3, I think. And to put that into perspective, smoking has a hazard ratio of 2. So a lack of strength in older populations is significant. And by strengthening early in life, you're almost putting strength into the bank, so to speak. And then by maintaining strength through maybe some resistance training or physical activity, as you age, you can maintain a significant level of functional mobility. So we often think of lifespan, but we also need to think of health span. How well are we functioning older as we age? As we get into our 70s and 80s, are we living independently? We could. You have the ability to do that if we do the right things for ourselves. If we're physically inactive throughout our life and don't supplement our physical inactivity with exercise or movement processes that promote physical activity, or activities that promote movement, I should say, then we're going to increase our risk for falling, increase our risk for non-communicable diseases, as well as have an end of life that doesn't look as appealing. It's not, you're to live in a assisted living facility, I don't think is necessary, barring disease and injury. I think we can all live very functional lives and also contribute to our communities as we age too. But we have to do the right things to keep ourselves healthy.
Right. Yeah. I often tell my patients that, the biggest risk for disability is just disuse, right? So there's so much that we can do to avert that and to, like you said, stay engaged. And I appreciate you putting the hazard ratio to give them sense of magnitude of how important strength and muscle mass is relative to even smoking. And I believe cardiorespiratory fitness is similar. The hazard ratio, the risk it poses to mortality is far greater than risk.
I believe VO2 max, the hazard ratio is about 5, which is the only thing I think that exceeds strength. Maybe strength and end-stage renal disease may be on par. That's how big of a deal a loss of strength is.
Exactly. And when people are thinking about, movement, physical activity, cardiorespiratory fitness, and strength, I always think, well, what is a person's goal? And then move backwards, right? So if someone came to you and said, my goal is to be able to get down on the ground with my grandkids and stand up, you may recommend, certain types of movement. If their goal is to live a very long life, and longevity is the key that is important for that person, the goals are different. Can you speak about how movement physical activity, cardiorespiratory fitness, and VO2 max, how they play a role in the different goals that people may have, and how maybe if there's a way to think about the different kind of categories, if you will, in terms of goals.
Yeah, so I think there's a big interplay with all of them. Cardiorespiratory fitness will help promote processes that will improve strength and muscle hypertrophy. In fact, you could do in an untrained individual, if you only did like sustained, steady state, zone 2, cardiac aerobic exercise, then you're going to increase strength and you're going to increase muscle mass in that untrained individual. And also, if you do the steady state aerobic activity at a low level, that enhances any type of strengthening activity that you do. You can have more strength afterwards, after a period of time, if you also complement that with some aerobic conditioning. So there's an interplay with our body systems in regard to our physiology. Muscle will increase if cardiorespiratory fitness increases. Doing exercise for the cardiovascular system, your respiratory system, and then strengthen it. So getting on an exercise bike is fine. Then doing isolated strengthening for our muscles is fine. That's also good, but you're missing a little bit of a movement component. And what I mean by that is you may not be able to do requisite movements that require you to move through a little bit more of a complexity. In other words, walking on an uneven surface if you find yourself at a park, or getting on up and down from the floor. I mean, you can have strength to do that, but if you don't have the mobility through your hip or your knees, etc., you might not be able to perform that movement task. So complementing maybe strengthening with, or utilizing perhaps a strengthening program that incorporates complex movement patterns, that looks at things like squatting or exercising your muscles through full ranges of motion, such as in a leg press, would be helpful in that regard. The other thing that's worrisome for an older individual is a lack of speed or power. If you look at what atrophies, we talked about how muscles atrophy through the later stages of life. But if you look at the muscle fiber type that atrophies, it's your fast twitch fibers. Slow twitch fibers remain pretty much intact, but it's your fast twitch fibers that are reduced. And those are the fibers that are necessary if you lose your balance. If you lose your balance, you need a righting reaction. Your foot's got to go out to the side quickly to steady yourself. If you don't have the ability to move your limb quickly like that, then you're going to end up falling. And, falls result in, over the age of 60, result in death, I think, within 2 years. I think it may be the highest risk factor for death at that age. And it gets worse as you get older. You combine that with a lack of metabolic health in bone, and fractures will happen a little easier, right? We don't fracture our hips or our bones when we fall from a standing height when we're younger, but we do when we're older. We don't have the skeletal structure to absorb those forces, nor do we have the neuromuscular control to help us overcome any loss or perturbation, loss of balance, to maintain our balance. So training for speed and for power would be important as well. And just keeping ourselves a little bit loose in regard to mobility, as well as understanding that there could be a play for things like plyometric activity, light running, even at an older age, in 80s and 90s. There are folks doing Ironman triathlons who are in their 80s and 90s. And so it's not beyond our capacity. I think it actually is well within our capacity. I think it's actually beyond our capacity to not do that, right? So if we don't do that, the detriment to our health is it's so apparent.
I appreciate you talking about how the role of each one of these plays out and the interrelationship, because certainly for a lot of people, the exercise of choice ends up being walking, for example, and it's a great exercise, but it doesn't touch on functional movement. It doesn't necessarily build all the strength and support all the muscle groups that we need as we get older. So it's really important to think about exercise in the way you're describing, with the functional movement, the strength resistance, the endurance type. And certainly designing a program, which we'll talk about in the next episode, of what does that end up looking like, I think is really, the part where it's the practical implementation. In terms of just thinking about exercise, health, and longevity, is there anything else you'd like to add?
we need to have an equal emphasis on health span as we do on lifespan, and understanding that medication is helpful in regard to both health span and lifespan, but it should be complemented with a movement process that ensures the functional mobility of the individual, especially as we age. We're getting into a more aged population. And I'm afraid that more of those folks are going to need more assistance. There's going to be more resources required to help them. There's going to be more of a burden on the individual because they're not able to move as readily. And all of that can be mitigated if a thought was provided to an individual at a certain point in life, maybe their 40s and 50s, that they have to remain somewhat active. And I think the key to that is not to promote maybe exercise or a gym-based environment, but have them find an activity, and it could be probably a social activity that allows them to remain active in some way. Even older individuals that are sedentary, if they start to do something, even as something seemingly as sedentary as a chess club or a book club, will get them out of the house and get them moving a little bit. And all that's meaningful for the person who's doing nothing. And so to push the bar a little bit higher for each individual based upon their individual circumstances is important. What I think we do is we start to do the opposite. We start to reduce our activity and start to reduce our life and close ourselves in, especially once we leave our professional obligations. There's not as much meaning to go outside of the house. And we have this attitudinal environment in Western culture where an aged individual is exactly that. Oh, you're retired, go ahead and relax. We'll kind of put you away, so to speak, where I think we can still have productive members of society, whether that's through employment or volunteer service or support groups, however that looks. I think that having the ability to participate in a meaningful way within your communities is super valuable. I think that provides the impetus to get yourself up and moving. Complement that perhaps with some more formal strength training, et cetera, and something that's enjoyable. And I think that is going to help our aging populations.
Yeah, and it's great that you mentioned that. Think about it, 40s and 50s, not to wait until a person is older and not capable of doing certain things, but that, starting early can make a big difference because there's so much age-related loss. So thinking about, how we all age is a really important component when we think about activity. So Peter, thank you so much for everything you shared. I'm looking forward to part 2, where we can get more into the details of what this is going to look like in our day-to-day lives.
Great. Thank you, Sharon.